calculate the sum of all the 3-digit numbers in base 11 which are divisible by either 12 or 18, and if s is the sum, we are required to calculate the remainder when s is divided by 7. So let us first calculate what is the smallest 3-digit number in base 11. The smallest 3-digit number in base 11 will be 100 in base 11. This will be equal to 11 square, which is equal to 121. And what is the smallest 4-digit number? The smallest 4-digit number will be 1000 in base 11, which will be equal to 11 which is equal to 1331. So what is the largest 3-digit number in base 11? The largest 3-digit number will be 1331 minus 1, which is equal to 1330. So essentially what we are required to calculate is the sum of all the numbers between 121 to 1330, which are either divisible by 12 or divisible by 18. So what we will do is we will first calculate the sum of all the numbers which are divisible by 12. Then we will calculate the sum of all the numbers which are divisible by 18. And then we will subtract the sum of all the numbers which are divisible by either 12 or 18, by both 12 and 18. That is, they are divisible by the LCM of 12 and 18, that is 36. So if S1 is the sum of all the numbers in this given interval which is divisible by 12, and if say S2 is the sum of all the numbers which are divisible by 18, and if S3 is the sum of all the numbers which are divisible by 36, which would imply that they are divisible by both 12 and 18, the value of S will be equal to S1 plus S2 minus S3. And what we are required to calculate is the remainder when this S is divided by 7. So what is the value of S1? To calculate the sum of all the numbers which are divisible by 12, what we will do is we will first calculate the smallest number which is a multiple of 12. Then we will calculate the largest number which is a multiple of 12. Then we will calculate how many numbers are there in that interval which are divisible by 12. The smallest number which is greater than 121, which is divisible by 12, is 132. And the largest number which is less than 1330, which is divisible by 12, is 1320. Then how many numbers are there in this interval which are divisible by 12? That will be equal to 1320 minus 132 divided by 12 plus 1. That is 1320 minus 132 divided by 12 plus 1. 1320 divided by 12 is equal to 110, minus 132 divided by 12 is 11 plus 1. So this is equal to 100. So there are 100 numbers which are multiples of 12 which lie between 132 and 1320. What does this imply? This implies that S1, which is the sum of all the multiples of 12, is equal to 100 divided by 2 into 132 plus 1320. Remember that if we know the first term of an arithmetic progression which is equal to A1, and if we know the last term which is equal to n, and we know that the number of terms is equal to n, the sum of the arithmetic progression will be n by 2 into A1 plus An. So here we know that the sum of all the multiples of 12 in that given interval is 100 by 2 into 132 plus 1320. Similarly, we will calculate the multiples of 18. What is the smallest multiple of 18 which is greater than 121? The smallest multiple of 18 which is greater than 121 is 126. And the largest multiple of 18 which is less than 1330 is 1314. Therefore, the number of numbers which are multiples of 18 which lie between 126 and 1314 will be 1314 minus 126 divided by 18 plus 1. This, if you simplify and calculate, you will get that this is equal to 67. Similarly, if you are looking for the multiples of 36, the smallest multiple of 36 which is greater than 120 is 144. And the largest multiple will be equal to 1296. Therefore, how many multiples of 36 are there in the given interval? It will be 1296 minus 144 divided by 36 plus 1. What is 1296 minus 144? This is equal to 1152 divided by 36 plus 1. What is 1152 divided by 36? This will be equal to 32 plus 1, which is equal to 33. So there are 33 multiples of 36 in the given interval. So S2, which is the sum of all the multiples of 18, will be equal to 67 by 2 into 126 plus 1314. And S3 is equal to 144 plus 1296 into 33 by 2. So the value of S1 will be equal to 50 into 132 plus 1320. What is 132 plus 1320? That is equal to 1452. And what is the value of S2? It is 67 by 2 into 1216 plus 1314. That is equal to 1440 divided by 2 is 720. This is 67 into 720. Similarly, the next number will be equal to 33 into 720. This will be minus. So S1 is 50 into 1452, S2 is 67 into 720, S3 is 33 into 720. All that we are required to calculate is the remainder when this is divided by 7. We don't really need to calculate all of them. So what we'll do is we'll simplify this. 50 is equal to 49 plus 1. So we can ignore 49, and the remainder when this is divided by 7 will be the same as the remainder when 1452 is divided by 7. And 1452 is 1400 plus 52. So the remainder will be the same as when 52 is divided by 7, which is equal to 3. And what is the remainder when 67 into 720 is divided by 7? 67 is 63 plus 4, so we can ignore the 63 part. So the remainder will be the same as when 4 into 720 is divided by 7. 720 is 700 plus 20. So the remainder will be the same as when 4 into 20 is divided by 7. 4 into 20 is 80. When it is divided by 7, the remainder is again equal to 3. And what is the remainder when 33 into 720 is divided by 7? 33 is 28 plus 5, so we can ignore the 28. So it is the same as 5 into 720. Again, as we discussed earlier, 720 is 700 plus 20. So the remainder is the same as when 5 into 20 is divided by 7. 5 into 20 is 100. So the remainder when 100 is divided by 7 is 2. So the overall remainder will be 3 plus 3 plus 2, which is equal to 4. So the required answer in this case is 4.